Hi, welcome back. Today we're going to be discussing the comparison test. Okay, and this is used for series. Okay, and the comparison test, it has two statements. So one statement, it says, so first our setup is let AN and BN be positive series. That just means that each value is greater than or equal to 0. Okay, and we're going to say that AN is less than or equal to BN. Okay, then we have the following statements. It says this. It says if the series of BN, the infinite series, if this converges, then so does AN. Okay. The second statement says if AN, the series of AN, diverges. Oh, and I need to put the conclusion here, so let me put the conclusions in red. Okay, and the conclusions are if Bn converges and every term of the series of An is less than Bn, then An also converges. Okay. If summation An diverges, then every term of Bn is bigger than An, so Bn also has to diverge. Okay. Here's going to be just a brief example. And the question is going to be, does this series series converge or diverge? Well, I'm going to use the comparison test. And one thing that we're going to note is we're going to note that this n over n to the fourth plus n plus 1. Hey, if I make the denominator a little bit smaller, like this, if I just drop everything other than n to the fourth, this term on the right is bigger, and this is going to be 1 over n cubed, and that's b sub n. And this term we're going to call a sub n. Okay. So we're going to claim that b sub n, all we need to do is claim that the series of b sub n converges. So this is the claim that this summation from n equals 1 to infinity of b sub n, this is just the summation from n equals 1 to infinity of 1 over n cubed. This converges by the integral test. Okay, and we'll just do that. So this series, the sum from 1 to infinity of 1 over n cubed, converges or diverges with this integral. Okay, and this integral, I'm just going to deal with the improperness. And I'm sorry, let's not use B, since I'm calling the series B sub n. Let's call that S, or let's call it T, okay? And we'll evaluate this antiderivative. And then we'll plug in. Okay, and this limit is going to limit to 0, and we're just going to get 1/2. So it converges. So summation from n equals 1 to infinity of this 1 over n cubed converges. Hence, summation from n equals 1 to infinity of a sub n, which is the summation from n equals 1 to infinity of n over n to the 4th plus n plus 1 converges. And notice we had to use two tests here. We had to use the comparison test and the integral test, and that's not uncommon. Okay, so we've proved that an converges via the comparison test. Okay, so just remember, the main takeaway from today is just this comparison test up top. Okay, thank you very much.